Alright, so we're going to use universal bank data. So let's first create the data source. Universal bank. So use advanced metadata advisor, and then we have interval, education, nominal. Okay, all right. So for a regression type of analysis, which discriminant analysis 1, there is no difference between nominal and ordinal. Experience, family could be, I don't know what we've done previously. Family could be made into an interval, or we can leave it as nominal, but let's make it interval. Alright, so the rest is good. Okay, so bring in the data set. And then we're going to, now one of the assumptions that we have here for discriminant analysis is that we have multivariate normality for the predictor. So each predictor variable follows a normal distribution, and that's not a big problem, because as long as we have enough number of cases, then we don't, the discriminant analysis is robust enough to handle that. Okay, so we have lots of data here, so that's not an issue, right? So if you look at imported data, right, and you look at properties, and then you see there are 5,000 cases, so that's good enough. The second assumption is that assumes correlation among the classes. So we have personal loan 0 or 1, so the correlation within 0 and correlation within 1, so two separate classes. Okay, they are all the same. Okay, so within the class, the same across the classes. Okay, the correlation among the predictors. So we can see that by running a correlation analysis. So I'm not going to do that. And sensitivity to outliers. So if you have outliers, you want to remove them, code them out as missing values, and probably impute missing values there. And another thing is that this is scale sensitive. So I'm going to rescale the variables using transform node, and we will transform the interval inputs. Okay, so we can use I'm going to use standardized, so it should be z-score. All right, and then let's split the partition to be, I have a pen here, data partition, and say we want 70%, 30%, and 0%. Okay, and then we do a SAS code. Okay, and code editor. All right, so if we, the simple, I have the code here, but if it is going to be a simple one like this, okay, let me show you that first. Okay, so here, so the first line is the same, no problem, and the class is a click variables, and then you can check out what the variable names are. So here personal loan, okay, personal loan role is the input. I forgot to change that, so let's go back here. Well, I have to get out of there. So go ahead and change. So edit, and personal loan should be changed to target. Now let's go back to code editor. Okay, so now the class variable should be personal loan. Here we can click, drop, bring it down and drop it. So that way we can avoid typos. All right. Then if you run, okay, so now we have the discriminant function, linear discriminant function for class equal to 0 and class equal to 1. Okay. So we can score with this, but we don't have any score data. So you go to export data, okay. So you get the transformed predictors, okay, and that's it. All right. So we want to export, we want the propensities computed and exported, then we have to add a few more lines, and those lines are right here. Okay. So I'm going to copy paste these lines, and then we will look at what they do. Okay. So we have the first statement right here. That's we used that before. It's importing the data, and then we are importing one more set of data. Okay, so that is called test data. That's a keyword, and we are setting test data equal to. Okay, it's also coming in to our node, our SAS code node. That's why it is import. So ampersand em underscore import indicates that this information is coming into the node from the previous node. Okay, and then underscore data is your train data, and underscore validate is your validate data. So you can review this from here. So here are the imports. So import data, so that's your train, and then we have validate right here, em import validate. So that's going to be used as test data. Okay, and then we have out. Okay, so that's going out. Now this time the expression used is ampersand em underscore export. So that means these data sets will be exported from this SAS code node. Okay. And if you go down here, scroll down, so you have exports, then you have the macro variable names associated with those data sets. So we have EM export train, so that's going to be the train data, and EM export validate, that's going to be the validate data. So that's going to be our test out. Test out is the test data going out. Okay, so that's again a keyword. So these three additional lines will give us what we need. Save changes, run. I know what happened. So each statement should end with a semicolon, right? So initially we had just that one line as the statement, it ended with a semicolon. Now we are adding all the additional information to the statement. So this statement actually ends here. So this is where the semicolon should belong. And I forgot to remove that semicolon when I added these additional information. That's the reason for the error. So I remove that. All right. Exit. Now run. Okay, so now we have the results, okay, the same results as before. Okay, so now if you go to exported data, okay, go to validate, then you see we have the propensity for 0, okay, that's _0, _1 propensity for 1, and it doesn't tell you what class the particular observation was put into, or predicted class. So this is your original target value, but what is the predicted value for personal loan? Okay, it's not in here, but it is there, but it is not displayed in the validation set. Okay. I'll show you how to get that in just a second.